Hello friends, good afternoon and welcome to EduSite Live Lectures. Dear friends, today in Network and Graphs, we will be talking about computer networks. To discuss this topic, we have with us our subject expert, Professor D.K. Lobial. Professor Lobial is Professor in School of Computer and System Sciences, Jawaharlal Nehru University, New Delhi. Without further ado, I would like to welcome Sir to our studios and request him to start the lecture. Welcome, sir.
Thank you very much. And the previous module, what we talked about is the layered architecture of computer network, and where we stopped at few of the layers of OSI reference model, where we talked about OSI reference model. And let me briefly recap a few things, and then we'll continue with what we discussed in the previous lecture. So what we said is that the OSI reference model came because of the proprietary network developed by various organizations, and therefore there was no interoperability possible, and therefore this 7-layer architecture to provide interoperability was developed by ISO standard, given standard by the ISO, and this is called Open System Interconnection System, which I discussed last time. And it has 7 layers, and I started with the layers from the bottom to the top, and we left in middle because the time was over. Now see what is said in the physical layer is only for the physical transmission of signals and bits from one system to another system, right, where the bits are converted into signals and signals are converted into bits, and what is the duration of a bit that is decided by the physical layer, and what should be the interface for the connectivity of a cable of a wire with the system, that is also part of the physical layer. Now that means how many pins should be in an interface card and what each pin should do. And in addition to that, the synchronization is important, that is what he said, because if a system is sending faster, the sender, and the receiver cannot accept that faster, so therefore the bit duration may be different, and you may send more number of bits which may be read a small number of bits by the receiver. So there must be synchronization, and there should be a link to link point to point connection, or it may be a shared link, that means multiple systems are sharing the link, and therefore or that the two systems have a direct connection, that means the connection is not shared by many systems, only this cable connects one end one system, other end other system. So and then how these connections are made, that is called topology, and then what we said is there are half duplex, full duplex, and simplex kind of communication modes. If you go back to 70s, it was possible. Now today all communication links almost are of full duplex in nature. Now the another layer we said is the data link layer, where the node to node transmission without error, this is the function of this layer. That means any error introduced by the physical layer, that means while data is being transmitted through a link, due to noise interference some error may be introduced. Since data is travelling in terms of bits, even if you forget about signals, the error could be seen only in terms some of the bits which were 1 now become 0, and some of the zeros becomes 1s, and therefore there is an error. And now therefore these errors has to be deducted first, that there is error, and if possible can be corrected, right. So to do that, the data is organized into streams, and then these streams or small group of we call frames, and they are transmitted. And then when the links are shared, that time we said when links are shared, then when the sender is transmitting and the destination address should be kept in the frame itself, so that when this frame is received by multiple systems in a shared link, then the system whose address is contained in the frame will be able to only manipulate that frame, and other systems who received the frame but since the frame is not addressed for them, they will discard the frame. So, that means what I am trying to say is to distinguish between different systems which are sharing a link, we must have an addressing mechanism, so that each system is uniquely identifiable in a network. So, unique addressing, that is what we call a MAC address in general, is required to distinguish between nodes or the systems. Now, the third layer is the network layer. This is very important, where see we have two networks. Now, till data link layer we talk about two systems communicating if they are part of the same network. Now, if you have two different networks placed far away from each other, then how to transmit? That means we said there should be routing devices in between which will deliver a packet from one router to another router, and so on and so forth. So, the OSI layer 3, which is called network layer, it does transfer data between different networks. So, within a network, nodes transfer among themselves, then at this end, if there is a network, it is transmitting data to another network. So, it is a multi-hop network, because one router to another router, then another router. If I assume that each router is connecting one network, so it is between different networks. So, that is what we call multi-hop network transfer. And therefore, now the addressing mechanism which was used at layer 2 will not function. The reason? Because the nodes are not in the same network. So, that means the sending at layer 3 or network layer in OSI model, what you assume is that a network is transmitting data to another network. So, therefore, each network should have a unique address. If you say this, so the sending network has an address and the receiving network has an address. So, when data is being transmitted from a network to another network, the data will contain the address of the network of the sender, and it will also contain the address of the destination network, and that is what we call a logical addressing now. And then this layer has to specify what should be the structure of the address. That means, what field should be in the address? It should only contain the address of the network, it should also contain the address of the host or the node. So, this is the mechanism, the addressing mechanism has to be specified by network layer, and this address we call a logical address, because this is not address of a hardware device or an equipment. And then in that case, looking at the network address, each router or a device will decide through which path the packet has to travel. Now, so another task of network layer is therefore to decide the path through which a packet will travel. Now, in addition to deciding the path, before a device, that is called a router, can decide the path for a packet, it must have full information about the network or internet. The moment I say internet, I am not using internet with capital I, internet with small I n t e r n e t. The moment I say small I, that means any interconnection of two networks is called an internet with small I. The moment I use capital I am referring to the internet today we use for searching various information. So, we are referring to the internet if I use capital I. So, here in the whole discussion why I use internet, I am using internet of multiple connection of multiple networks. Now, that means in that situation all intermediate nodes, that is router, should have information about the links between various networks. That means I can see that the links between various networks can be seen as a graph, or even the links between various nodes in a network can also be seen as a graph. Now, that means if I have a information of a graph, then I can find a shortest path in the graph, and that is the path the router has to decide before it can transmit the packet from one network to another network. That is what is the task of a network layer in OSI model. Now, the network layer in OSI model can be connectionless or it could be connection oriented. The moment I say connectionless and connection oriented, here before transmitting of a packet, whether a connection is established between the two network, that is source and destination, and then packet is transmitted, that is what you call a connection oriented. And if not, that you do not establish a connection or do not determine a path, and you keep on transmitting the packet from one router to another router, and then see what is the next hop, only then you transmit. That means you are not bothering about establishing a connection. So, the OSI model, it assumes that the network layer in OSI model may be both connection oriented as well as connectionless. Now, and it also OSI assumes that the protocols for the various network layer may be determined by those who are interested to implement them. So, they do not describe what protocol should be used at what layer level. They will only describe the layers and their functioning. Now, the next layer specified by OSI reference model is transport layer. Now, what is said is the basic function of a data link layer is to transmit data from one interface card to another interface card within a network between two hosts and two systems. So, let me call it, it is a host to host communication, or rather to call it, it is a communication between a network interface card to another network interface card. So, that means there is an entity which is participating in communication is a network interface card. Next network layer which I talked about is that entire network, that may be a full machine on a network, is communicating with other network. So, that means now what I said is the interface to interface communication. Now, let me call it a machine to machine or from a network to network communication. Now, that is not sufficient, that even if a data is transmitted from one network to another network, ultimately within a network there is a host or a system which actually is participating in the communication. If that is happening, then ultimately if the network layer has delivered the packet, it has delivered the packet to the destination machine. Now, within the machine, the multiple processes may be running. Now, say for example, you may open Internet Explorer on your machine and search something, then you can open another instance of Internet Explorer, maybe through one instance of Internet Explorer you may be searching something on Google, maybe through other you may be opening your email, or you may be not only opening Internet Explorer, you may have a Netscape. So, two different processes you are opening, and then two different processes are communicating. So, when say the Yahoo server transmits data to you, it comes on your machine by network layer communication. When it comes to a machine, now it has to go to the right process. If you are communicating to Yahoo through your Internet Explorer, and that it must be communicated to the Internet Explorer process. So, when it is transmitted to the exact process, only then user will be able to use the information. Now, while doing so, now ultimately what we are doing is a process on the source machine is communicating with a process on the destination machine. So, ultimately at the end, if you look at it, is a process to process communication. So, now what you see is we have three entities which are participating in communication. First we said network interface card, two interface cards are communicating. At the upper layer in the hierarchy we said it is a network to network communication. Even at we go top we said that it is a process to process communication. After that what? if the message is received by a process, then a user is free to look at the message. So, the communication is done. So, that means the process is the last entity which is participating in the communication. So, that means it is the end entity which is participating in the communication. Therefore, we call it end to end communication. So, one of the function of transport layer is end to end connection. The other function we specify here is that the network layer also has, the transport layer also has to specify the address of a process, so that they are uniquely identified within a host. That means, if the host machine is running multiple processes, if a message comes to the host, to which process the network layer should deliver the message. So, therefore, transport layer is assigning a unique address to each process that are running on a host, so that the message is delivered to the right process. And the another task of the transport layer in OSI model is the segmentation and reassembly of data. That means, what is said? The data is divided into small groups at the hardware layer or the data link layer, we call them frames. When the data is divided into small groups at the network layer, we call them packets. Now, similarly, a large message is divided into small groups at the transport layer level, we call them segments. Now, the segments is also have to be reassembled at the destination process or the machine. When it is delivered to the process on the destination machine, the segments may arrive through a different path, may arrive through different order. So, that the first segment transmitted by the sender may not be the one which reaches first at the destination, it may be the second one, and therefore, combining them in the right order is another task of the destination process. That means, the transport layer also provides a function to reassemble the segments, and on the sending side it provides a function of dividing the message into segments. Now, therefore, at the transport layer we have two kind of services, either we can have connectionless or connection oriented. So, transport layer in OSI model supports both kind of communication, either connection oriented or connectionless. So, this also, the transport layer also does end to end flow control and data control. That means, end to end flow control means that it must make sure that the segment size which is being transmitted from the sender should be only that much that it can be accommodated by the buffer available in the receiver side. If the space in the memory of the receiver is not much small, then only a small segment should be transmitted by the sender, so that it can fit into the buffer of the receiver, otherwise there will be overflow. So, that means, one of the function of the transport layer is to check that how to control the flow of data between two processes. That means, before they start transmitting, they must have some kind of exchange of information, so that the size of the segment fits into the buffer size, and it may also have some error detection and check and correction possible, if possible, detection is there. So, transport layer also does error detection and correction if it is connection oriented. Connectionless, we do not bother about the error detection, maybe at times, or we are not bothered about whether the segments are reaching in the order or not, and whether they are put in the right order or not, because in a connectionless service, the primary motive is to deliver data in time, rather than the order is more important, rather than the order, the timely delivery of the data is important. That is what we call it is a best effort delivery system. It try to make a delivery to deliver the segment timely. Like in a postal system, if you look at, you deliver a telegram or a letter, you drop in the letter box and they make a best effort to deliver in time, and you do not know whether it has been received there or not, and you assume that it will be received by the recipient. Now, another layer here is a session layer. See, nowadays, though we have full duplex links, when we have half duplex links, then the problem was because at a time one side can send, other side has to listen. When one side finishes, the other side has to transmit. So, in that situation, what happened was who will start first and when, who will send when. So, therefore, there must be a dialogue between the sender and the receiver, so they can manage their transmission of data, that will send first and when one has sent and the other will send. So, the dialogue management is one of the function of the session layer, and it also must maintain a synchronization between sender and receiver. That means, if the data is transmitted, that some portion of the total data is transmitted and the connection breaks and system gets down, and if you resume again, whether you will resume it from the same point or you will start sending from the beginning. That if you have to start resume from the same point where the connection was broken and the data transmitted, then it must maintain some kind of checkpoints. So, it maintains how much data has been received, and that is the starting point now. So, that must also exchange some information and maintain certain synchronization. This is another task of the session layer, and it also provides a mechanism of creating a session from a user, that how long a user will be logged into the system, and when its communication is over, it will break or end the connection. The another layer is a presentation layer, and this layer, because different systems use different kind of communication, and therefore, to deal with that, like if you look at some systems may represent integer, that it will keep that the big byte, because integer consists of 2 bytes, the big byte comes first and the little byte comes afterward, or vice versa. If the format of the data is not in the same way, that means when the sender sends data in ASCII format and the receiver does not understand ASCII, it may be using Unicode, then what will happen? So, the 2 bytes of ASCII will be considered 1 byte of Unicode, and to avoid that, how to maintain the same format. So, the presentation layer deals with the syntax and semantics of information being interchanged. That means, what format the data has been transmitted. So, one of the tasks may be to translate data into one format to another format, and therefore, and in addition to that, it may also provide encryption and decryption of the data, and further compression and decompression of the data, so that a large amount of data can be sent in a small period of time. And the topmost layer in OSI model is application layer, and this application layer will provide that even if you are able to transmit data from one system to another system, now how do you decide what data to be transmitted, right? So, therefore, it must provide some services, and these services are to be decided, like whether you have to transmit an email, whether you have to transfer a file, and so forth. All these services has to be decided. So, the application layer deals with providing the various kind of services, and some of the services are standard services like your email, your file transfer, and so forth. And you can also decide your services, and that is what the part of the application layer. Thank you. What we discussed about is the OSI layer architecture. Now, another architecture which is a very dominant and prominent architecture, which is used in internet communication even today, is the TCP/IP reference model, and that is the TCP/IP stands for Transmission Control Protocol, that is for TCP, and IP stands for Internet Protocol. And this is one of the protocol which is implemented today. And this protocol, if you have listened to the previous part or previous lecture, where it says OSI is a 7-layer model. There are 7 layers defined for that. And for TCP/IP, it is called a 4-layer, or some call it 5-layer model. Now, why it is so that some of the layers in TCP/IP does not exist? And if you look at the diagram, what I have given the comparison of OSI and TCP/IP model. And if you look at the physical and data link layer, we call a host to network layer there, and then in TCP we have a TCP/IP, we have an internet layer, then we have a transport layer, finally we have an application layer. Now, if you look this way, it is a 4-layer architecture, and below this host to network layer, you can call it a physical layer. If you call it this way, it becomes a 5-layer model. Now, leaving aside whether it is a 4-layer and 5-layer model, now how it functions and how it is implemented. And the most important part in TCP/IP is the protocols are also defined for each layer. Now, if you look at this, the presentation layer and session layer are missing in TCP/IP model, which were in OSI model. If we try to draw a parallel, what you see is the transport layer exists in OSI model, transport layer also exists in TCP/IP model. There is a network layer in OSI model, and the correspondingly we have called an internet layer, though it may not be one-to-one mapping, but still they match to the large extent. And then instead of calling data link and physical layer, we call host to network layer, and application layer exists in both. Now, what happened to the presentation and session layer? Now, if you look, what was the functions of presentation and session layer? And the one of the task of the presentation layer was to encrypt and decrypt data for the security reasons, and the other aspect was to compress and decompress data, because the bandwidth, if you are sending a larger packet, it will consume more bandwidth. If you compress into small size, it will be transmitted faster. Say for example, if you have to send 1 MB data, and if you compress it, we make it half MB data, then total time of transmission will become half. So, you will send more data in the same time. So, that is where the compression and decompression is important. And the third thing we said is that another task is of, if there is a difference in the syntax and semantics of the data which is being transmitted between the sender and receiver, you need some translation, that the format in which the sender is sending must be translated into the format in which the receiver understands. That means, example I said, if data is being transmitted into ASCII and the receiver only understands Unicode, for example, then this ASCII data has to be translated into Unicode. Now, this happened because earlier the different manufacturers were designing with different kind of encoding system, one, and therefore, the translation between encoding systems was one of the important factors. Now, with the evolution of time and the computer network, we arrive at a standard called ASCII. Now, whether it is IBM making its machines, or Intel, or Zilog, or anybody else, they will follow that their data representation is in ASCII format. So, you do not need translation now. And second is, even if there is small portion of translation required, that some stores data in big endian integer in big endian form and some stores in little endian. So, that means big endian needs to be translated into little endian. Now, for a small fraction of translation, do you really need a separate layer? No, I think we do not need a separate layer, one. And second is that all applications may not require compression and encryption and decryption. That means, until unless you need secure transmission of data, you do not need to decrypt and encrypt. Only sensitive applications requires that their data should be encrypted and therefore decrypted. Like say for example, if I am simply transferring a file, I do not need it to be encrypted and decrypted. Probably, definitely any defense application will require that their data must be encrypted, but not if I am sending an email, I will not need that it should be encrypted and then transmitted. So, that means encryption, decryption is not a requirement of each and every application. Then why should I have a separate layer for encryption and decryption? And second is, with the, as you see that the bandwidth increase day by day, and do you really need to compress? Yes, of course, still we need to compress. While we are transmitting a large size video across the network, probably we need to compress it. But to send few kilobytes of data in email, do you really need to compress and decompress it? Now, the time you consume in compression and decompression may be much more than the actual time taken to transmit a small amount of data. Therefore, only few applications will require compression, decompression, encryption, decryption, and largely most of the formats are standardized. Only few changes may be here and there. So, do you need for this a separate layer? No. So, that means where applications has a demand, you let them compress, decompress, and encrypt, decrypt, rest should not. And small differences may be taken care of a transport layer. Why to have a separate layer for small differences? And second is that the function of the session layer, if you look at what is said session layer, one of the tasks of the session layer is dialog management. Now, most of the links are full duplex links. I do not think now walkie-talkie except, you will not say across that anywhere in communication we are using half duplex. So, therefore, if the links are full duplex, then do we really need to have a dialogue before exchange of data? No, we do not need. So, not required. And the checkpoints can also be taken care of at lower layer or higher layer by transport layer. So, therefore, we do not need to. So, small functions which are still needed may be done by transport layer. So, therefore, these two layers are gone. Now, let us see what each layer of TCP/IP does. Now, before we go in details, let us look at this diagram. Why this diagram is important? At the lowest level, if you look at what is said a physical plus data link layer, which is combined in a network interface card. So, you do not, especially TCP/IP does not need to do anything. That means, if you are using a local area network, you may be using Ethernet card, you may be using token ring card, you may be using FDDI card, fiber optical cable, you may be using a packet radio, so separate card for wireless, you may be using a satellite network, SATNet. So, therefore, a different card may be used, and the ARPANET was using a different card. So, depending on your requirement of a network, whatever kind of network, you buy a card and put into your network or your devices. So, that means it is out of the domain of a TCP/IP protocol. So, it is hardware dependent. So, the data link layer and physical layer are implemented in hardware. So, now the important point, what you call an internet layer, is part of your TCP/IP, and in between the internet layer you should have the IP, what you call internet protocol. One of the protocol designed for internet layer in TCP/IP is called internet protocol. Now, this protocol, therefore, what you need is you need an interface between this internet layer and the physical and data link layer, which call ARPANET, SATNet and this. Therefore, there is a host to network layer, because internet layer is a network layer equivalent, and these LAN cards or other cards of LAN packet radio or ARPANET or satellite, they are part of the host. So, therefore, you need a layer which is called host to network layer in between. So, if there is an interface, you can put any card and that will start working with the TCP/IP protocol. Now, over internet protocol, where there is a IP protocol or internet layer, then we have another layer called transport layer, and this transport layer provides more connection oriented and connectionless service. Therefore, TCP/IP model has defined two protocols for transport layer. One is TCP and another one is UDP. And TCP stands for Transport Control Protocol, which is a connection oriented protocol, and UDP stands for this is Transport Control Protocol, or this is a datagram protocol, and that is user datagram protocol. And the moment say user datagram protocol, it is a connectionless service. UDP provides, or user datagram protocol provides a connectionless service, whereas TCP, that is transport control protocol, which is a connection oriented protocol. So, it provides you connection oriented service. So, that means on IP, if you look at below, IP protocol is a connectionless. So, over a connectionless protocol, which is IP, you can have a connection oriented protocol running or a connectionless protocol running. And at the application layer level, you have multiple standard protocols running. It is a telnet for remote login is an application protocol. FTP is a file transfer protocol, which is used for transfer of a file from one system to another system. Then another protocol of application layer is called SMTP, that is simple mail transfer protocol, which is used for transmission of or transfer of emails. Then here a domain name service, which is called DNS, is also used by internet. So, these are certain or some standard application protocols which are designed and implemented by those who are providing you TCP/IP protocol. That means, the TCP/IP protocol comes along with the operating system as the integral part today. If you are implementing a Linux, TCP/IP, that is IP layer IP protocol, UDP and TCP protocol, plus these applications Telnet, SMTP, FTP, DNS, all these standard protocols are part of the software package coming as a operating system. Windows has its own, so that means you do not need to buy it separately, but there are only few standard services which are implemented, but you can also design your application. So, new application, if you need to be used in the internet for your own purpose, then you have to implement your own application which can be used for communication. Now, look at how each layer in the TCP/IP work. Now, when you talk of, we will talk on two important layers. Internet layer, it uses an internet protocol, IP protocol, that defines its own format. That means, what information this protocol should contain in addition to the data, so that the communication is possible, is the format which is defined by the internet layer and IP protocol. So, one of the tasks of this is, it will deliver an IP packet from one host to another host, or from one network to another network, and this provides a connectionless service, and it does the task of packet routing. That means, a packet from one network should be delivered and routed to the another network, and that is the function performed by internet layer or internet protocol at internet layer. That means, when it provides a routing mechanism, that means it must decide to which network or to which router the packet has to be delivered. And to do that, it must have an address, and the address provided by internet protocol is called IP address. So, that means the IP address has its own format and each packet carried by internet protocol will contain IP address in the header of the protocol. So, that means since IP is a connectionless service, when a packet is delivered at a router, say a router, and then this router has to decide. Now, it may be connected with 3-4 routers, say router B, C, D. Now, it has to determine whether the packet received has to be further forwarded to the router B or to router C or to router D. Now, because it will determine that if I send it to router C probably, it will be delivered to the right destination. So, how it decides? So, the router A will look at the IP address in the header of the packet, and depending on the address, that IP address contains the network address. Now, it will determine that okay, it is the address of so and so network. So, therefore, it will be right to deliver this packet to this router, so that it is delivered to the right network. So, what it is doing is the network address, because the IP address consists of two portions. One portion is a network address, other portion is host address. So, it will look at the network portion address of the IP and then decide the route. So, in addition to that, the internet layer or the TCP IP also has to provide certain routing protocols that are supported by TCP IP. And to certain extent probably this can also do some congestion control, but the internet layer in TCP IP though does not provide much of the congestion mechanism, and it does not avoid any kind of congestion. Now, the transport layer, which we said is a process to process communication, and it is, as we said, the transport layer in TCP IP provides both kind of services, connection oriented and connectionless, and it defines two protocols. As I said in the beginning, that transmission control protocol is your connection oriented protocol and user datagram protocol is a connectionless protocol. Now, this transmission control protocol, as we said, is a connection oriented protocol. It will add, since it is a protocol, it should have a protocol data unit. It will provide its own header. That means there must be an addressing mechanism provided at transport layer. So, the TCP IP at transport layer also provides sequence number 1, TCP will provide a sequence number, so that the TCP segments delivered out of order can be put in the right order by the destination by looking at the sequence number in the header. So, even if they did not reach in the right order, and before doing transmission of a data, the TCP also does a handshake. That means it must establish a connection because it is a connection oriented protocol. Now, when it establishes a connection, what does it do? The connection establishment means we call it handshake. That means the sender must transmit some information to the receiver and receiver must inform back. That means it must send some acknowledgement, and based on that acknowledgement the sender must say that yes, we agree, and that is what the three-way handshake, which sender sends, receiver responds, the sender also agree too, and that is a three-way communication before it can finally start communication. Therefore, we call it a three-way handshake. And what does it do in three-way handshake? That means, as we said that the transport layer also provides or controls the flow of the transmission, so that the buffer of the receiver does not overflow. That means, in the beginning, one three-way handshake is being done. The sender in the transmission control protocol say that, okay, my buffer size is this much and I will use this sequence number in the beginning. All this information it can send to the receiver, and receiver will say, yes, I do agree, and while I am transmitting, my sequence number will start from there and my acknowledgement will start from there, and my buffer size is so much, and therefore it sends to the sender. Now, the sender, by looking at what information receiver has sent, it must agree to that whether communication is possible or not. If it assumes, by looking at the information sent by the receiver, it will inform to the receiver again, yes, the communication is possible. That we call, in a three-way handshake, some negotiation is carried out between the sender and receiver. That is what the connection establishment mean. It does not mean that you have a physical connection between a sender. That is what we call, the connection may refer to a logical connection. Whereas, if you look at the telephone communication, when you establish a connection, what happens is, the moment you dial up a number of a recipient, the whole from which exchange to which exchange the message, the call will go, they have to book or reserve a link. So, during that period, only two parties who have established a connection will communicate, nobody else can share that link. So, there is a dedicated connection there, but in case of data transmission in TCP/IP, we do not have a dedicated connection. So, here connection establishment means negotiation of the information, so that the exchange of data can take place smoothly. Whereas, in UDP, it is not a connection oriented, therefore, the connection will not be set up. That means, the negotiation of the information, control information, or a three-way handshake will not be done between the sender and the receiver. That means, the moment the sender gets data, it will start transmitting to the receiver. Whether it reaches out of order or in the order, whether there is error or there is no error, it does not matter. The reason is that the timely delivery of a information is important. Let me give an example, is that, say, if you are watching a cricket match, live cricket match, you will be more interested to look at the event what is happening live, rather than the quality of the picture. Even if the quality of the picture is not of very high standard, it is of the acceptable level, that everything is visible, then you will find you like that the information should be delivered to you timely rather than delayed. That means, you would never prefer that whatever is transmitted to you, transmitted after 5 minutes. So, the whole enjoyment of watching a match gone. Therefore, what you need is, so the time you spend on connection establishment, if you need that the all quality information should come to you, even if there is a delay, then the enjoyment is gone, because you get the delayed information, probably which you might have heard from somebody else what happened. So, the timely delivery of a message here is more important than the quality of the information. So, therefore, we not like to have a connection establishment. So, with this we will complete this TCP/IP protocol, and thank you.
On that note, I would like to thank sir for his very enriching discussion, and thank you, dear friends, for watching our show. Stay tuned and keep watching. Thank you.